Introduction. The dinner is quite delicious and I'm enjoying it very well.
Yes, Dad. I agree with you. I'm also enjoying the dinner.
Son, please pass me the salt.
Sure, Dad.
Son, will you answer my one question?
Yes, Dad. I will try to.
Okay, so tell me, why the sugar and salt particles have different structures?
Maybe due to different constituent particles?
Son, your answer is right but not appropriate. I will tell you. Every structure depends upon the nature of chemical bonding between them. In sugar, there is covalent bonding in the molecules, whereas in salt, there is ionic bonding in the molecules.
Okay, Father. I got the reason and I want to know some more about that.
Students, today we will study more about the chemical bonding and molecular structure. Objectives. At the end of this lesson, you will be able to define chemical bonding, understand octet rule and Lewis symbols, define ionic bond, know about the factors affecting the ionic bond, explain properties of ionic compounds, define bond parameters, describe resonance structure, know about polarity of bonds. Definition. Most of the substances in nature exist in the form of molecules, which are the cluster of atoms of same or different kinds. The attractive force which holds various constituents together in different chemical species is called chemical bond. The chemical bonds can be classified into various types like ionic bond, covalent bond, coordinate bond, metallic bond, hydrogen bond, and van der Waals forces. Coastal-Lewis approach to chemical bonding. The developments in the field of atomic structure provided foundations for various theories of valency. The initial contributions in this field came from W. Coastal and G. N. Lewis in 1916. They were the first to provide some logical explanation of valency, which was based on the inertness of noble gases. Octet rule. The rule states that atoms of various elements enter into chemical combination so as to attain the configuration of 8 electrons in their outermost shell. They do so either by transference of electrons or by mutual sharing of electrons. Lewis symbols. According to these notations, the symbol of the element represents the nucleus as well as the electrons in the inner shells. The electrons in the outer shell are represented by dots surrounding the symbol. The number of dots represent the number of valence electrons. The common valencies of the element can be calculated from the valence electrons. The common valency of the element is either equal to the number of dots or 8 minus the number of dots. For example, the common valencies of lithium, beryllium, boron and carbon are 1, 2, 3 and 4 respectively, while those of nitrogen, oxygen, fluorine and neon are 8 minus number of dots, that is 3, 2, 1 and 0 respectively. Example on Lewis symbols. Let's take an example on Lewis symbols. Use Lewis electron dot symbols to represent the transfer of electrons from magnesium to fluorine atoms to form ions with noble gas configuration. Let's see the solution. The Lewis symbols for the atoms are: the Mg atom loses 2 electrons to attain a noble gas configuration, but F atom can accept only 1 electron to fill its valency shell, so 2 F atoms must take part in electron transfer. We can represent this electron transfer as ionic bond. Ionic bond is formed by the transference of 1 or more electrons from one atom to the other. Generally, this type of bond comes into existence between a metal and a non-metal atom. The metallic atom loses its valency electrons and changes into a positive ion called cation, while a non-metallic atom gains electrons and gets converted into negative ion called anion. The oppositely charged ions are held together by electrostatic force of attraction.